fire narration है.
So let me start with another lecture on moment distribution method. In the last lecture, we were discussing about the beam questions. Now we may discuss further about, let's take a question related to frames. Can we have the audio muted of everyone? Let's take a question of frames. Let there be a frame now. This is a frame. It is fixed here. It's simply supported at this location. Then let it be fixed here, and let this be fixed at this location. Or we can take, let this be, there be a hinge here. This is a hinge support here. This is fixed. This is simple support. Now let us take the loads. There is a load acting. This is one load. There is another load acting here. And then let on this panel be a UDL load acting here. This be a UDL load. Let's take this load as 5 times T. This is 10 times T. And here, which is a UDL, it's 1 times T per unit run or unit meter. Now the distances. Let this length be 12 meter. Now I have another, this is again 12 meter. Then this is 8 meter. Now this here, this length, the vertical length, this is 8 meter. This length here is 12 meter, or say 10 meter. Now the loads are acting at, this is acting at center, so it's acting at 6 meter for this panel. Similarly, it's acting at 6 meter at the center for this panel. And now these are, this is A support, this is B support, say this is C, then you have this as D, this as E, and this is F. These are the supports that we have. So now this frame is fixed at A and it's simply
Sir,
supported at D.
are you audible, sir? Hello?
Yes?
Sir, sorry to disturb you, but some students are saying that they are waiting in the admit room, so please admit them.
All right. So what I was discussing is that at A, this is fixed. Can we have the audio muted? It's at A, it's fixed, and at D, it's simply supported. It's connected at B, but this is a rigid connection at B. Similarly, there is a rigid connection at C, and there are two columns here. One is BE and other is CF. Then there are three beams. One is AB, other one is BC, and the third one is CD. Now these are once it's fixed at one end, so and the columns are also fixed, then we come to a conclusion that this is a non-sway condition. This is a non-sway condition. Now, what is a sway and a non-sway condition? In a sway condition, you have that the frame is laterally able to deflect. But here, because E is fixed and A is fixed, the frame will not laterally deflect. So it's a non-sway condition. Lateral deflection means the deflection that occurs in this direction or the deflection that occurs in this direction. So now you have come to know that it's a non-sway condition. Thereby, in a non-sway condition, there are no additional horizontal thrusts generated in the frame. So now let us try to resolve this question by the moment distribution method. So in the moment distribution method, we already know that the first step is that we fix all the end conditions. Now, how do we do that in this case? And how do we plot it? Let me draw a table. Now in this table, let's first take the joint. The type of joint that we have. Then let's take the support. Now what are the supports that we have? We have support A, B, C, D, E, and F. So there can be two ways of making this. Let's first make the horizontal profile only here. Now A is here, then you have B somewhere here, then we have, let's take the first part here, E, and then C. But we also have further supports which are F, and then there is D. Now let's forget for the time being F and D. Now at joint, what are the various joints A, B, E, and C that we have taken initially? Now at A joint, what are the members that are connected first? let's take the members that are connected at A joint. There are two members. There is only one member connected at joint A, that's AB. So you have AB. Now at B, how many members are there? There are three elements, BA, BC, and BE. So there are three elements. BA is one, BC is other, and BE is the third one. You have BA, BC, and BE, three elements connected at B. Now at E, there is only one member, that's EB. And at C, there are again three elements, CB, CF, CB is one, CF is other, and CD is the third one. So we have three elements connected at C. Now, just give me an idea about what do we do next? How do we proceed? We fix first all the connections, isn't it? We fix all the connections. Now, what will be the moment at F and D finally? Because both are hinged. Finally, the moment at both these will be 0. But first, we are fixing all the connections. So let me take the fixed end moments first. Fixed end moments. What will be the fixed end moment? Last time we discussed this, when there is a point load, it's either WA Q by L square, or you have WL by 8. You have WL by 8. Is that right? WL by 8. So it will be minus WL by 8 for AB at end A, and it will be plus WL by 8 for AB at end B. So how much is this now? If this is 5T, W is 5T, L is 12. Now you can calculate, anyone, 5T into 12 divided by 8, that is 7.5. So this is minus 7.5. At end B, for BA, this will be plus 7.5. Now for BC element, at again this is the load 10T is at center. So again this is minus WL by 8 at this end, and this is plus WL by 8 at the other end. So for BC, it's minus W is 10T into L is 12 divided by 8. So it's 15 times, this is 15 times T. This is also into T. This is also into T. So for BC, it's minus 15. Now for CB, which is here, this will be plus 15 into T. So now for BE, there is no load acting on element column BE laterally. There is no load acting on BE laterally. So what will be the fixed end moment? For B, at end B, it will be 0. Now for EB, what will be the fixed end moment at end E? Again, it will be 0. There is no lateral load acting on the column. Now for CF, at end C, what will be the load acting at end C? Because there is no lateral load, so again CF would be 0. What will be the load if this was fixed? Now first let's calculate CD. So for CD, when both are fixed, C and D is fixed, then it becomes minus WL square by 12, and this becomes plus WL square by 12 at the other end. तो कितना आ रहा है? It's 1T, W is 1T, 1 into L is 8, 8, 8, 64 divided by 12, so it's 5.33. So CD is minus 5.33, right? Let me calculate it again. Yes, so CD is minus 5.33. Now there are two more joints, F and D. Now let us add F and D, but this will hardly make any difference to our calculations. But we have to calculate the carryover from here. So one joint is, this is F, and the other joint is D. Now at F, the element connected is FC, and at D it's DC. Now for FC, because there is no lateral load acting at F, the moments will be 0. When CD is fixed and D is fixed, then the moment at D is plus 5.33. Now, what is step number 2? This is step number 1. Can you now explain to me what happens here once I first calculate the fixed end moments? What do I do next? I calculate the, yes, someone? You calculate the releases. Now, where are the releases happening? Just tell me, where will the release happen? Where do we release the fixed end moment? Anyone? Anyone with the answer? Where do we release? We release at end F, and yes, Shahid is saying at D. But F is also hinged. It's not fixed, it's also hinged. So we're releasing at both F, but the release at F would be 0 because the load already, the moment already is fixed and moment is 0. But at D, it's minus 5.33. That's the release that we have to make at support D. So what do we get after doing the release? Yes, someone. What do we do after
Carry out moments.
carry over? It's carry over, and we do the carryover of the release only. Now the release has happened only actually at D. At F it's 0. So at D, when the release was minus 5.33, where will the carryover moment go? Somebody? Where will the carryover moment go? कहाँ जाएगा वो? Yes, someone? To which support will the carryover go? Shahid is saying C. So yes, he's right. The carryover will go to C towards which member? It will go towards CD. So how much is this? Minus 5.33 divided by 2. How much is that? It's 2.67. These are all into T. I've forgotten to add T in here, add T here, add T here, and this is into T. So the carryover that has happened is minus 2.67 towards CD. What do we do next? We add them all like we did the last time around. So our next step is addition. We are adding now from top to bottom to the red line. We are adding all the moments. So this will be minus 7.5 into T. This will be plus 7.5 into T minus 15 times T. This is 0, 0. This is plus 15 times T. This is 0. How much is this? 5.33 minus 5.33 minus 2.67. That's 8 into T minus 8T. This is 0 and this is 0. So once we have added all of these, now at each support, for example, at A support, the overall moment and at moment is minus 7.5 T. At B, it should be stable. So if it's stable at B, BA, BC, and BE together, this should be 0. The summation of moments at B should be 0. But as we see, they are not 0. If we add BA, BC, and BE at B, at E, similarly, there is a fixed moment, then which is actually 0 here. At C, the three moments CB, CF, and CD, they should be equal to 0. They are not. Similarly, at F, it's already 0, and at D, it's simply supported it's 0, 0. Thereby, what do? We distribute, we do the distribution. We do the distribution at this point. Now, give me an idea of how do we calculate the distribution factor here. Now, let us say that the moment of inertia of whole frame is I. It's I. Now, can you do the distribution here? How? You have to calculate the stiffness factors of all elements. Now let us calculate the stiffness factors for AB, then for BE, then for BC, then for, sorry, uh, BA is first, then BE is next, and then BC is third. This is at joint B. I had to calculate the distribution factor. So I have to calculate the stiffness factors of all these three elements. Now for BA, the other end A is fixed. So it will be I divided by L. L is 12. Now for BE, it's the other end is fixed. It's I divided by L. That's 10. For BC, it's I. The other end is continuous. It's I divided by 12. So the distribution is in form of 1 by 12 is to 1 by 10 is to 1 by 12 for these three, BA, BE, and BC. Now 1 by 12 is 0.083, 1 by 10 is 0.1, and 1 by 12 is 0.083. So this ratio is, if I first 0.083 divided by 0.1 is 1 is to 0.83 is to 1. So sorry, it's opposite. 0.83 is to 1 is to 0.83. So this is the distribution factor at joint B. So I can write down the distribution factors first. Let me first write down the distribution factors here. For at joint A, there is only one element, so you do not need to calculate the distribution factor here. At joint B, now for BA, distribution factor is 0.83. For BE, it's 1. BE, it's 1. And for BC, it's 0.83. Now let us move to joint C, where you have three more elements, CB, CF, and CD at joint C. Now CB, the other end B is continuous. So this will be I divided by L, that's I by 12. Now for CF, the other end F is simply supported. So it will be 3 by 4 of I by L. L is 8. Then for CD, the other end D is simply supported. So you have 3 by 4 into I by 8. Now, how much is this? This is 1 by 12 is to 3 by 4 in 3 by 4 divided by 8.9375 into I is to, again, 3 by 4 I by 8. So it's 0.9375 into I. So 1 by 12 is already 0.083. is to 0.9375 is to 0.9375. So 0.083 divided by 0.9375 is how much? It's 0.083 divided by 0.99375. I'm getting this wrong. 1 by 12. 3 by 4. 8. This is 0.09375. 0.083 divided by 0.09375 is 0.88, or you can take 0.989 is to 1 is to 1. So this is the distribution factor at joint C. For CB, it's 0.89. For CF, it's 1. For CF, it's 1. And for CD, it's 1. Now for at joint E pe there is only one member, so you do not need to determine the distribution factor here. Then at joint F and D, similarly, you have only one member connected, no distribution factor needed at F and D. Thereby, now we have the distribution factors. What do I do? This I'll put in another color, so thereby you do not add this up while you are adding. This is not to be added. Now, next, what do? I distribute the load now. Sorry, the moments now. Let me distribute the moments. Now this is after distribution. Now there is no need of distribution at this point. No distribution happening here. You do not need to do it here. You do not need to do the distribution here. No distribution here and no distribution happening here. Where do you do the distribution? You do the distribution first at B. Now what is the total at support B? Now what's the total load at support B? It's plus 7.5 T for BA. This one. This is plus 7.5 T. So it's plus 7.5 and then minus 15 T for BC. For B, it's 0. So the total load that you are getting, total moment that you are getting at support B is minus 7.5 T. So the distributed moment would be yes, how much? Plus 7.5 T, the opposite sign of it. Now, in what ratio do we distribute it? For BA, it will be distributed in the ratio of, yes, anybody? We'll restart the session.